Alright, so we're back. This is video number 2 for the rate times time equals distance problems. Alright, so we have a girl here who drove to her cabin on the lake and back. Trip took 5 hours and the trip back took 4 hours. She averaged 8 kilometers per hour faster on the return trip than on the outbound trip. Find the average speed on the outbound trip. Okay, so we're going to let X represent ultimately what we're looking for, and that's the speed outbound. It means going there, right? Going to the cabin. So X represents speed. Let's go ahead and make our table. So again, we have somebody traveling to a destination and then returning home. Right, so we have outbound, so going to the cabin, and then we have the return trip home. Right. So let's make our table. Let's label our columns: rate, time, and distance. The trip there, so that's outbound, took 5 hours. So outbound, 5 hours, that's my T. The trip back took 4 hours. So we put 4 in for T for the return trip back. She averaged 8 kilometers per hour faster on the return trip home. So again, outbound, we know X represents the speed outbound. So that's where X is going to go for the outbound rate. But again, we got to be careful, because she averaged 8 kilometers per hour faster on the return trip home. So we're not just going to drop an 8 into this box. Right? And she traveled 8 kilometers per hour faster returning than she did going there. So faster means X plus 8, right? So if the speed going there was X miles per hour and she went 8 kilometers per hour faster and returned home, so that's why it's going to be X plus 8 and not just 8. Okay, so because it says 8 kilometer hours faster, it did not say she averaged 8 kilometers on the return trip. It's faster than the outbound trip. Alright, so we got our rate column filled in, our time column filled in, so now we're going to fill in the distance boxes. Again, it's rate times time. Rate times time. Again, because it's that situation where we are going to a destination and return trip, when it comes to writing an equation for distance, okay, going there and coming back, the distance traveled is the same. They are equal. Outbound and return trip, same distance. Okay, so I'm going to go ahead and solve this one. Should be 4. 4x from both sides, and I get x is equal to 32. Right, so that is her speed going to the cabin. It was 32 kilometers per hour. Alright, move on to number 6. So we have here a student left the Science Museum and traveled east at an average speed of 42 kilometers per hour. Another student left sometime later, traveling in the same direction at an average speed of 70 kilometers per hour. After traveling for 3 hours, Ashley caught up with Julio. How long did Julio travel before Ashley caught up? So we're trying to find Julio's time. So we're going to let X represent the time Julio traveled. Ultimately, what we're looking for, how long did Julio travel? That's it. Alright, set up our table. We got Julio and Ashley. We got rate, time, distance. Alright, so 42 kilometers per hour, that's Julio. Ashley, 70 kilometers per hour. Okay, so again, Julio left first. So Ashley left sometime later. So Julio left first in the same direction. So she's basically trying to catch up to Julio, right? They're both traveling in the same direction. Julio left first. Ashley left later, going in the same direction. After traveling for 3 hours, Ashley caught up with Julio. Okay, so we know Ashley for sure has been traveling for 3 hours. Again, we don't know Julio's time. So we're going to let, again, that's X. Okay. So here we have our rate filled in. We have our time filled in. Just like before, we're going to fill in the distance column by multiplying the rate times the time. 42 times x, 42x, 70 times 3, 210. So now again, we're going to be writing the equation using this distance column. Okay. But now, we don't have, again, a value for distance. Right? It's not a situation where, like the other ones, we are setting them equal because that the return trip or trip going somewhere and coming back is the same. But we are going to set them equal for another reason. So again, for this one, we're setting up for another reason. Is because Ashley is going to catch up to Julio. Okay, so again, if you think about the concept of catching up to somebody, right? That person left first, and you're going to go after them. You're going to chase them down. Okay? So if you're fast enough, you should be able to catch up to them. And when you do, that means you travel the same distance that that person traveled. Right? If you're leaving from the same spot, one person left first, and you left later. If you travel fast enough, you're going to catch up to that person. And when you catch up to somebody, the distance traveled is exactly the same. Okay. So again, you can solve for x, and that should give you what Julio traveled as far as time. So it's 210 divided by 42. So that's fine. Okay, so Julio traveled for 5 hours. Again, it makes sense, right? Julio left first, so his time should be bigger than Ashley. Alright, last one. A jet left Rome and flew north. A passenger plane left 2 hours later, flying 86 miles per hour faster in an effort to catch up. So again, here's another catch-up problem. After 5 hours, the passenger plane finally caught up. Find the jet's average speed. Alright, so we'll let x represent the speed of the jet. We'll make our table jet and passenger plane. Rate, time, distance. Okay, let's go back here. So a jet left Rome and flew north. A passenger plane left 2 hours later, flying 86 miles per hour faster. Okay. A passenger plane left 2 hours later, flying 86 miles per hour faster in order to catch up to it. So a passenger plane is driving faster or traveling faster than a jet. I had to think about that one for a little bit because to me that kind of makes sense. But whatever. Alright, so if the jet speed is x, the plane is going 86 miles per hour faster, so that means its speed is going to be x plus 86. Right? Jet speed plus 86 miles per hour. It wants to go faster than jet. After 5 hours, the passenger plane finally caught up. So a passenger plane was traveling for 5 hours. Right? A jet, 7, right? A passenger plane left 2 hours after flying. Right? 2 hours later. So that means the jet has been flying for 7. Right? So the passenger plane was traveling for 5 hours. That means the jet was traveling for 7. Distance, rate times time. Rate times time. Okay? Again, it's another situation of catching up. So when we write our equation, we're going to set them equal to each other. All right, solving for x. 86 times 5, so that's 30, give me 3, 3. There you go. Alright, so the jet's average speed was 215 miles per hour. Alright, so that's it for this day's video lesson. And if you have any questions, make sure you contact your teacher. You guys have a great day.